In this video, we will be discussing some practice questions regarding the concept of tension. In the previous videos, we discussed about push and pull uh, regarding force with angle along a horizontal plane. So yeah, this is just a continuation of what we've started. This is the third lesson. So for question 1, an object is hanging steadily on the ceiling. The tension of the wire is 200 newtons, so we're looking for the mass. So first things first, you have to know that in this particular problem, there is only an arrow up and an arrow down. There's no movement that's specifically stated with respect to the x-axis. So it's the object isn't like going there or there. It's just in the scenario, either it goes up or it goes down. But specifically here, it says that the object is hanging steadily. Therefore, the summation of forces with respect to the y-axis is equal to 0 newtons. We know this because the object isn't moving. Therefore, it's 0. And that also happens given that the scenario is given that it provides details regarding the potential movement of the object with respect to the x-axis. Although this is true regarding our scenario, it's not exactly relevant to our solution with the intention of looking for the final answer. So we know that summation of Fy is equal to, well, supposedly this is in another scenario, the force going up is supposed to be the normal force, or N, and the arrow down is supposed to be the weight. The only difference with this illustration compared to this illustration of number 1 is that the tension, this object is hanging or suspended from above with a wire or some sort of string. And here, it is assumed that the object is on a surface and it's not suspended on anything from above. So yeah, there is still essentially the same. The only difference is that this is tension, the other is normal force. Anyways, so now that we know that, hang on for a while. Sorry about that. Yeah. So back to where we are. Summation of Fy is equal to N minus weight. But in our scenario, this formula can be tweaked as T minus W instead. So we know that summation of Fy is 0 newtons and tension is said to be 200 newtons. By the way, we can write that separately just to be organized. But these are the given. This is directly given, this one is implied. What is the mass of the object? That's the missing thing. And yeah, how do we look for the weight? There's another formula. The beautiful weight is equal to mass times the gravitational acceleration. We do know the value of summation Fy and tension. Therefore, we can look for weight. So I suppose we transpose weight to the other side, and then there, that's it. We know that weight is 200 newtons, and utilizing the formula that was written earlier, 200 newtons, then put the mass there. Gravitational acceleration is 9.8 meters per second squared. What is the answer? So 200 divided by 9.8 is equal to 20.40816 kilograms. I do hope you have your cycle with you. It's going to be important. So next, actually we don't really need much space for the first question, so we'll adjust the second question. So a 0.9 kilogram object, so we do have the mass. We know that this is mass. Well, for one thing, you know that the unit is kilograms. Kilogram is the, I suppose, yeah, it is the SI unit for mass. If provided that the units of specific names, particularly regarding mass, or for instance, say distance or length, maybe it's not in meters, then you have to convert it to meters. As much as possible, the answer is supposed to be in SI units, unless stated otherwise. So, yeah. T1 and T2 are missing. And we all know that the object is being supported, therefore the summation of force with respect to the y-axis is equal to 0 newtons. And we all know that the formula, again, is tension minus weight. Or with our kind of scenario, we can tweak the original formula into something like this. Since realistically, we do have two tensions. You have two wires. So combine the tension of the two wires, then you make up all of the tension that concerns the illustration. So yeah, 0 newtons. And how do we know the weight? We use the same formula as a while ago. This time we know the mass, so that's important. And then we multiply it with the gravitational acceleration value, which is always going to be 9.8. 0.9 times 9.8 is equal to 8.82 newtons. Now, that weight will be placed here. T1 plus T2 minus 8.82 newtons. 8.82 newtons transposed to the other side. We have something like this. And how do we know what is the value of T1 and T2? And based on the illustration, it is easy to think. It's not difficult to think that T1 is equal to T2. Why? Because most likely, or yeah, it's just look at it. The object isn't suspended in a way that, say, the length of the other wire is longer compared to the other, which makes the object look like that. So naturally there's more tension here because the wire is shorter. But then that's not the case for what we have right now. The tension, because the wires are the same in length, they're evenly distributed. Therefore, we can say that T1 is equal to T2, and that say T1 is equal to T2. We just divide this value by 2. It's going to be 4.41 newtons. So that is the answer. So yeah, let's move on to the next. Okay, I believe you have to use another paper for this, another page. So now the wires are illustrated this way, but nevertheless the tension is the same, as well as the angle. So we are supposed to look for the mass, given that T1 is equal to T2 is equal to 13 newtons. And that, how do we describe angle 1 and angle 2? For one thing, we do have these two formulas. T1y is equal to T1 sine theta, and T2y is equal to T2 sine theta. they're essentially the same. The only difference is that this is for tension 1, this is for tension 2. So T1y, let's go to T1y. We have to look for T1y given that T1 is equal to 30 newtons, and then the angle theta is said to be 45 degrees. Now 30 sine 45, that will be equal to 21.21320 newtons. So T2y is equal to 30 newtons sine 45. Why? Because they're basically the same as the former. So T2y is equal to the same value as T1y. Okay. But wait, why did I box the answers that we have? They're not exactly the final answers yet, so don't box them. Now, we have to look for the mass. And speaking of the mass, we remember earlier that the summation of Fy is equal to T minus W. But here we have tensions 1 and 2. So diversify the T here, make it T1 plus T2, and everything else is the same. Why is the summation of Fy equal to 0 newtons? Well, again, the object is being supported. There's no movement. It's not falling. It's not flying. So 0 newtons there. How do you determine the weight? We do have T1 and T2. Or here we can say that it's T1y, T2y. Why? Because here it's the summation of Fy. So naturally everything here is related to y, or the y-axis. So 21.21320, you just multiply that by 2, it's going to be equal to 42.4264 newtons. We'll transpose weight to the other side. This is going to be the weight value. Now we know the weight, and we ought to look for the mass. Therefore, we substitute 42.4264 newtons is equal to mass times 9.8 meters per second squared. Mass is equal to what? It is said to be equal to 4.32922 kilograms. Okay, so that's it for number 3. Let's go to number 4. A 90 Newton person, so I can say that this is the weight. The unit for weight is the same as the unit for tension, which is in newtons. Balancing at the center of the thread, form 10 and 5. So what are the tensions? T1 and then T2. Again, we know that the summation of Fy is equal to 0. The guy is balancing, or the girl, whoever that individual is. And summation of Fy is equal to T1 plus T2, and then subtract the weight. Summation of Y is equal to 0 newtons. But before that though, we have to utilize this formula. T1y is equal to T1 sine theta. T2y is equal to T2 sine theta. T1y is what we're looking for, which is this, as well as T2y, which is that. So T1 is equal to, well, we don't know. We do have the weight, so let's see. The weight is equal to mass times gravity. So 19 newtons is equal to mass times 9.8 meters per second squared. Mass is equal to 9.18367 kilograms. Okay. I don't think it's relevant to look for the mass at this point. Um, so, yeah, this is where we have to um, involve the summation of fx, because as you have noticed here, there is we don't only have one arrow which is going down, so you also have an arrow going to the right and left. Therefore, it concerns the x-axis. We need to look for the summation of forces with respect to the x-axis, whose formula is equal to t2x minus t1x. That's it. Or originally, for this kind of formula, it's supposed to be the applied force minus the uh, frictional force, or in other words, just F. But this is with respect to the free body diagram. Um, what we have right now is more complex, and yeah, essentially it's the same concept. This is FA, um, this holds the place of friction. In a scenario where the object or person is not on level with the ground. I'm thinking this is an example that is related to bungee jumping, or whatever you call that thing. It's like you're jumping in a trampoline. Trampoline material is elastic, I think, if I'm not wrong. So, anyways, the person is balancing, therefore, summation of fx is equal to 0 newtons. And t2x is what? Okay. So, we have to calculate for t2x and t1x. t1x and then t2x. This time, the formulas for these guys, it's still the same. For t1x, it's still going to be t1, but then this time you put cosine. What's the difference between this and this? Well, for y, remember that it's going to be sine. For x, it's going to be cosine. So, t1 is what? We don't... Wait, no. I don't think we have to find those things at the moment. Okay. At this point, let's do some algebra. So from here, t2x minus t1x. t1x transpose to the other side, and then we have something like this. Naturally, I think that's true because let's say this is 2 and this is 2. 2 minus 2 is 0. So, yeah, makes sense. 2 is equal to 2. So from there, if that is the case, we can say that t1x, which is this one, is equal to t2x, which is this one. So, we do have the angles, but we do not know what t1 is. So 10 degrees and 5 degrees for t1 and t2 respectively. t1 cosine 10 degrees is equal to t1 cosine 5 degrees. And then butterfly method. Hang on. No. This is supposed to be t2. Okay. So, say we have to look for t1 first. Divide both sides by cosine 10. So we have something like this. And from there, this is where we apply, we make use of the T1y and T2y, or at least just the T1y. So T1y is equal to T2 cosine 5 over cosine 10 degrees. Hang on, wait. Let's use the calculator first. You can simplify this further. So cosine 5 over cosine 10, that's equal to 1.01156 T2. Okay, we'll use this formula. So summation Fi is equal to 0 newtons. What is T1y? T1 sine theta. And then T2y is T2 sine theta. And then minus the weight. We know that the weight is equal to 19 newtons. Where do we find that? It says here, 19 newton per son. So 0 newtons is equal to T1. T1, as we know it, it's this. So 1.01156 T2, and then sine. For T1 it's 10, and then T2 sine, and then 5 degrees minus 90 newtons. 90 newtons is equal to, if you simplify all of this, this is going to be equal to 0.262811 times T2. Therefore, T2, 90 divided by 0.262811, that is equal to 342.4514195 newtons. So yeah, we already found tension 2. One more requirement, we need to find tension 1, which is easy. You'll just use the same formula earlier. So T1 is equal to 1.01156. Multiply that with 42.4514195 newtons. T1 is equal to 346.41016 newtons. Okay, that's it for number 4. So I think it's better to make an exclusive space for this. Okay, next, number 5. So a 600 Newton object is supported by the 2 wires. One wire is horizontally attached to the wall. The other wire formed a 50-degree angle horizontal to the ceiling. So what are T1 and T2? We need to look for the 2 tensions again. I believe this is 90 degrees. So weight is equal to 600 newtons. And what's next? We know that the object is supported, so the summation of force with respect to the y-axis is equal to 0 newtons. That also goes the same for summation of fx. What are the formulas of these summation values? Summation fy is equal to what? T1 plus T2 minus the weight. That's for summation Fy. How about summation Fx? I hope you remember this. Summation Fx is equal to... forgot. T2x minus T1x. Okay, it's best to do this in this kind of scenario. So T1y, T1 sine theta, T2y, T2 sine theta, T1x is equal to T1 cosine theta, T2x is equal to T2 cosine theta. So we don't know what T1 and T2 are. We know that the weight is equal to 600 newtons. We can look for the mass. So M is equal to W over G. M is equal to 600 newtons over 9.8 meters per second squared. Need more space. Mass is then equal to 61.22449 kilograms. This is just a side quest. I don't think that's going to be useful for the rest, for finding the actual answer. So yeah, I think these are more important to work on. So we need some algebraic manipulation once more. 0 newtons is equal to T1y plus T2y minus the weight, which is 600 newtons. 600N is equal to T1y plus T2y for T1x. Let's see. So T2x minus T1x. T1x is equal to T2x from that situation. Therefore, we can make these equal to each other because of this. So T1 cosine theta is equal to T2 cosine theta. T1 is equal to... Sorry, before we do that, before we proceed, we just have to substitute theta values. So for T1, I believe that's 90 degrees. And then the other, for T2, it's going to be 50 degrees. So from there, T1 is equal to T2 cosine 50 degrees. And then the denominator will be cosine 90 degrees. Okay, now let's use that here. T1y is equal to hang on, we can still simplify this. I keep forgetting the need to simplify. So cos 50 over cos 90, what is that equal to? according to the calculator, it's a math error for some reason. How come? Okay. I'm thinking of another solution that's a little more believable compared to the answer key of my teacher. T1y plus T2y. They're definitely not equal because of how the wires of the corresponding tensions are um, layouted, if that's even a word. What if we try this? T1, you know that T1y is T1 sine zeta. Zeta for T1 is 90. According to the calculator, this is equal to 1. And T2y, we have T2 sine zeta. We still keep the 600 Newton weight. For T2, sine is 50. And according to my teacher's answer key, this just suddenly disappears for some reason. Although this is 1, 1 times anything is still equal to 1. Maybe this becomes 601 or 599. This just becomes 0, essentially. And T2, you divide both sides by sine 50. T2 is then equal to 783.24437 newtons. Okay, so from there, what T2 is this? T2y. I almost forgot to write the complete details. So perhaps we use this one. Okay, what is T2? 783.24437 over sine 50 is equal to 1022.45291. let me try a trick. 1022.45291 cosine 50 over cosine 90. It's still a math error if I use this. Something about this thing, it's very cursed. Although I think um the solution before we came up to this kind of thing is correct. For some reason it's wrong. Ten to 2.45291 cosine 50. Cosine 50. You have to look for T1. No, wait a second. Okay, let's start fresh. I'm sorry if this has wasted your time. Let's use another variant of the general formula. So for summation fy, that's going to be equal to t2y minus w. And then for summation of fx, that's going to be equal to t2x minus t1. This is so weird. But I guess if you can encounter an illustration like this, then yeah, you use these two formulas. These are only specific for this kind of scenario. So again, summation of Fy is 0 newtons as always. T2y, how do you find that? T2y is equal to T2 sine theta. So I suppose put T2 sine 50 there in place of T2y, and then we know the weight, which is 600 newtons. T2 is therefore equal to 600 newtons over sine 50 degrees. That is equal to 783.24437 newtons. Okay, we found T2. So far, using this formula, we don't have any issues. Let's go to finding T1. How do we find T1? Maybe we look for T2x first. Okay, so T2x is equal to 503.45978 newtons. So T1 is essentially the same. Okay, next. A stoplight weighing 100 newtons was... Wait lang. How many... Okay, so this is our last question. Good. A stoplight weighing 100 newtons was hung at an angle of... Okay, this is definitely 90 degrees. Sorry, I just mentally calculated that. Those two values, they amount to 180. Sum of angles of a triangle is equal to 180. And the stoplight, the weight is equal to 100 newtons. You could use a bigger W. So what are the tensions of the wires? Yeah, this is gonna be pretty challenging. W is equal to mg. 100 newtons mass times 9.8. I'm pretty sure this is not going to be relevant to looking for the actual answer, but might as well solve it. So the mass is 10.20408 kilograms. Okay. Let's enumerate all of these T1y, T1x, T2y, T2x. T1y. Hang on. We do have these two other formulas. These are gonna be very important. To which summation Fy is gonna be 0. As you can see, the object is supported. It's not moving. That also goes for the horizontal axis. So you might ask why. You might ask for the reason as to why I don't have T3 in the formula. Well, yeah, according to guidelines, it's not really part. Just imagine the boxes without a T3. And yeah, we're back to the usual formulas that we used in this problem. Yeah, this and this. So 0 newtons is equal to T1y, T2y. Okay, T1, T1 cosine 37 degrees. T1 sine 37 degrees. What's the weight? 100 newtons. This is gonna be nice. Wait, no. This is wrong. It's supposed to be T2y, not T1x. So for T2y, T2 cosine, what's the degree or the theta for T2? 53 degrees. So T2 cos 53 degrees. So working on the summation of fx, maybe we can work something out to find, to see, because it's either we look for T1 or T2, and yeah, it's not possible to look for either of the two if we have T1 and T2 at the same time. Maybe it's better if it is better. This is not subjective. It's better if you have T1 T1 or T2 T2. So let's see what fate decides. T1x is T1 sine 37 degrees. T2x is T2 sine 53 degrees. Okay, so T1 is equal to T2 sine 53 degrees over sine 37 degrees. So sine 53 over sine 37. This is 1.3274, and then T2. So subbing, T1, this is going to be instead 1.32704 T2 cos 37 degrees. And then T2 cos 53. Okay, so 100 newtons has already been transposed, so that's good. We just have to simplify. So 1.32704 cosine, sorry. What's wrong with my calculator? 1.32704 cosine 37 plus cosine 53. We can group these two terms since they have the same variable T2, or let's say both are variables x. It's a matter of algebra in that sense. 1.66.164 T2. So 100 divided by 1.66164 is equal to 60.18151 newtons. So we now know what T2 is. Let's look for T1. 1.32704 times 60.18151. This is equal to 79.86327 newtons. Okay, I think we did it. So, what did we learn so far? From my mistake earlier, this is important to note. So we use these two formulas if we have a scenario where, say, T1 is like that and T2 is like that. They're diagonal, basically. But here, in this kind of scenario, if we have one tension diagonal, in a diagonal form, and one is horizontal, well, this is the formulas that we use. No exception. You don't use these formulas. Otherwise, it's going to be more confusing and most likely you'll get the wrong answer. Unless you find a way. That's not really generic. But it still works anyways. It should. And yeah, that's it. This one, for this, you use the same formulas for the summation of x and y. Of forces with respect to the x and y axis. Use the same formulas as these. Oh yeah, we didn't really use it here, but yeah. These are important. This is pretty easy. The formula here is just the summation of Fy, which is tension minus weight. And yeah, I think that's it. We answered 6 problems for this video. And yeah, that's all. Thanks for watching.